Tonight, step outside and look up. There, suspended in the velvet darkness like a luminous pearl cast into an infinite sea, hangs our most faithful companion. The moon has been watching over Earth for over 4 billion years. Yet tonight it seems as mysterious as it did to the first human who ever gazed upward and wondered in this moment of stillness. As shadows dance across lunar craters and the pale light bathes everything in silver, you're witnessing something far more profound than celestial scenery. You're looking at Earth's guardian, a silent sentinel whose gravitational embrace has shaped not just the rise and fall of our oceans, but the very rhythm of life itself. Ancient cultures knew this intuitively. They built stone circles to track lunar phases, timed their harvests by moonlight, and wove stories connecting this celestial wanderer to everything from fertility to madness. They understood something we're only now rediscovering through modern science. The moon isn't just a beautiful object in our night sky. It's the conductor of Earth's most fundamental symphony. Consider this remarkable fact. Without the moon's steady presence, our planet would wobble chaotically on its axis like a spinning top losing momentum. Seasons would shift wildly. Ice ages could last for millions of years, and the stable climate that allowed complex life to evolve would never have existed. Every breath you take, every heartbeat that carries blood through your veins, owes its existence to gravitational forces that reach across nearly 240,000 miles of empty space. But perhaps the moon's most visible influence lies in something we often take for granted: the eternal dance of tides that shapes our coastlines, guides ocean currents, and synchronizes the reproductive cycles of countless species. These rising and falling waters aren't merely the result of lunar gravity. They're Earth's pulse made visible, a planetary heartbeat that has been keeping time since life first emerged from the primordial seas. As you stand beneath this ancient light, breathing air that carries the faint salt scent of distant oceans, you're participating in a cosmic relationship that predates human civilization by billions of years. The same gravitational forces that pull the tides also tug gently at the water in your cells, connecting your biological rhythms to the greater dance of celestial mechanics. That tonight's moon may appear serene and unchanging, but it holds secrets that span the entire history of our solar system. Hidden within its gravitational influence lies the story of how worlds are born, how life learns to keep time, and how even the smallest celestial body can become the guardian of an entire planet's destiny. What mysteries might reveal themselves as we explore this ancient partnership between Earth and its silver companion? Long before there were oceans to fill with tides, before there was even solid ground to stand on, a cosmic catastrophe gave birth to the most important relationship in Earth's history. Picture our young planet, still molten and chaotic, spinning faster than we can imagine in the violent nursery of the early solar system. Then came the impact, a collision so tremendous it defied comprehension. A Mars-sized object, which scientists have named Theia, struck Earth with such force that both worlds were nearly destroyed. Billions of tons of rock and metal exploded into space, forming a ring of debris around our wounded planet that glowed like a second sun in the sky. From this cosmic violence emerged something beautiful: the moon. Over thousands of years, gravity pulled the scattered debris together, forging it into the luminous sphere that now graces our nights. But this wasn't just the birth of a satellite. It was the beginning of a gravitational marriage that would fundamentally alter the destiny of both worlds in those early eons. The moon hung much closer to Earth than it does today. Where we now see a silver coin in the sky, our ancestors, if they had existed, would have witnessed a looming disk 15 times larger, casting shadows so sharp they could cut glass. The young moon's proximity created tides of unimaginable power, walls of water hundreds of feet high that reshaped continents with every surge. This wasn't destruction, it was creation. The moon's gravitational embrace served as Earth's stabilizer, preventing our planet from tumbling chaotically through space. Other worlds in our solar system, Mars, for instance, lack such a massive companion and wobble unpredictably on their axis, experiencing climate extremes that would make complex life nearly impossible. The dance between Earth and Moon operates on principles of exquisite precision. As our planet spins beneath its lunar partner, the moon's gravity reaches down through the vacuum of space to lift entire oceans, creating bulges of water that travel around the globe like permanent waves. This isn't just physics, it's choreography on a planetary scale. But here's where the story becomes truly remarkable. Every tide that rises and falls steals a tiny amount of energy from Earth's rotation and gifts it to the moon's orbit. This cosmic friction has been gradually slowing our planet's spin while pushing the moon farther away, inch by inch, year by year. For billion years ago, a day lasted only 6 hours. Today, it stretches to 24. And the process continues. The moon moves away from Earth at about the same rate your fingernails grow, imperceptibly slow by human standards, but dramatic over geological time. This means our celestial partnership is slowly, inevitably changing. In about 5 billion years, if both worlds survive the sun's eventual expansion into a red giant, Earth and Moon will become tidally locked, with the same faces always turned toward each other, like eternal dance partners frozen in an embrace. Modern laser experiments that bounce light off reflectors left on the lunar surface by Apollo astronauts confirm this ancient process continues today with meticulous precision. Each measurement adds another data point to a story that began with cosmic violence and evolved into cosmic harmony. As we contemplate this 4 billion year waltz between worlds, we begin to understand that the moon isn't just Earth's companion. It's the architect of the conditions that made life possible. But how exactly does this distant dance translate into the rhythms that govern life on our blue planet? Imagine standing on a cliff at dawn, watching as the ocean below transforms before your eyes. The water rises with patient determination, claiming beaches that were dry moments before, filling rocky pools with marine gardens that had been empty caverns. This isn't just water moving. This is the planet breathing, inhaling and exhaling in rhythm with forces that span the cosmos. The tides are Earth's most visible connection to the cosmic dance we explored earlier. Twice each day, the moon's gravitational pull lifts billions of tons of seawater, creating bulges that travel around our planet like slow-motion tsunamis. But unlike the destructive waves that make headlines, these tidal waves bring life, carrying nutrients from the deep ocean to coastal shallows, exposing rich feeding grounds for countless species, and creating the rhythm that countless creatures have used as their calendar for millions of years. Along the rocky coasts of Maine, where granite cliffs meet the Atlantic, you can witness this ancient breathing in its most dramatic form. The Bay of Fundy experiences tides so extreme they seem to defy nature. Water levels that rise and fall by 50 feet or more, turning vast mudflats into deep harbors twice each day. Local fishermen speak of the tide as if it were a living thing, something with moods and personality, something that must be respected and understood. Rather than simply predicted, these aren't just local phenomena, they're part of a global system of oceanic breathing that connects every coastline on Earth. In the Mediterranean, tides whisper gently against ancient harbors where Phoenician traders once calculated their voyages by lunar calendars. Along the Pacific shores of California, tidal pools reveal themselves like hidden treasure chests, exposing sea anemones, starfish, and hermit crabs to brief moments of air and sunlight before the waters return to claim them. Ancient civilizations understood this breathing intimately. Egyptian priests tracked tidal patterns along the Red Sea coast, timing religious ceremonies to coincide with the highest waters. Polynesian navigators could sense the presence of distant islands by reading subtle changes in tidal patterns, feeling how waves bent and curved around underwater mountains hundreds of miles away. To these ocean peoples, tides weren't just scheduling convenience. They were the pulse of the world itself. The breathing extends far beyond what we can see from shore. Deep ocean currents, driven partly by tidal forces, carry warm water toward the poles and cold water toward the equator, moderating Earth's climate and making vast regions habitable. The Gulf Stream, that river of warm water flowing northward through the Atlantic, is influenced by tidal mixing that helps maintain its strength and consistency. Even more remarkably, the ocean's breathing creates its own weather. As tidal currents flow over underwater ridges and through narrow straits, they generate turbulence that mixes surface waters with deeper layers, bringing nutrients from the depths to feed microscopic plankton. These tiny organisms, invisible to the naked eye, form the base of nearly every marine food web and produce much of the oxygen we breathe. In estuaries and coastal wetlands, where rivers meet the sea, tidal breathing creates some of Earth's most productive ecosystems. Salt marshes pulse with life as tides flood and drain the grass-covered flats, carrying nutrients in and organic matter out in an endless cycle of renewal. These tidal nurseries serve as breeding grounds for fish, feeding stations for migrating birds, and storm buffers that protect inland areas from hurricane surges. The breathing never stops, never rests, never varies from the celestial schedule written in orbital mechanics and gravitational mathematics. Yet within this cosmic precision lies infinite variety, spring tides that surge higher when sun and moon align their gravitational forces, neap tides that whisper more gently when celestial bodies pull at cross purposes, and local variations created by underwater topography, coastal geometry, and the Coriolis effects of Earth's rotation. As we listen to this planetary breathing, we begin to understand that we're witnessing something far greater than the movement of water. We're observing the visible manifestation of cosmic forces, the translation of gravitational mathematics into biological opportunity, the rhythm that has guided life's development for billions of years. But how did ancient cultures, lacking modern understanding of orbital mechanics, come to revere this breathing as something sacred and mythical? In the flickering light of ancient fires, storytellers once wove tales that captured truths our ancestors felt but couldn't yet explain. They spoke of moon goddesses who drew silver threads through dark waters, of sea spirits who danced to celestial music, and of tides that carried messages between the earthly and divine realms. These weren't mere fantasies. They were humanity's first attempts to comprehend forces that connected their daily lives to the vast machinery of the cosmos. The ancient Greeks saw Artemis, goddess of the hunt and moon, as the divine archer whose silver bow pulled the strings of earthly tides. Her Roman counterpart, Diana, was said to bathe in tidal pools at the dark of the moon, her luminous skin causing the waters to glow with ethereal light. Sailors would time their departures by her phases, believing that a waxing moon would fill their sails with favorable winds while a waning moon might strand them in deadly calms across the Pacific. Hawaiian tradition speaks of Hina, the moon goddess who taught mortals to read the ocean's moods. According to legend, Hina's tears fell into the sea during her monthly cycle of sorrow and joy, causing the tides to rise and fall in sympathy with her emotions. Master navigators could supposedly hear her voice in the sound of waves against their outrigger hulls, guiding them across thousands of miles of open ocean, toward islands they had never seen. The Celtic peoples of Britain and Ireland developed perhaps the most intricate mythology, connecting lunar cycles to tidal magic. They believed that during certain moon phases, the boundary between the world of the living and the realm of spirits grew thin, allowing supernatural forces to flow through tidal waters like invisible currents. Druids would gather at stone circles during spring tides, when these mystical currents supposedly reached their greatest strength, to perform rituals that aligned human activities with cosmic rhythms that in Norse mythology. The giant wolf Fenrir was bound by magical chains that grew stronger during the full moon, when tides reached their peak power. The Vikings believed that high tides carried the favor of sea gods, while low tides might strand their longships in enemy territory or leave them vulnerable to supernatural attacks. Their concept of tide luck influenced everything from battle plans to marriage ceremonies, with major events timed to coincide with favorable lunar phases. Native American tribes along both Atlantic and Pacific coasts developed sophisticated lunar calendars that integrated tidal knowledge with seasonal hunting and gathering cycles. The Tlingit people of Alaska spoke of ravens stealing the moon and placing it in the sky to regulate the tides that brought salmon to their rivers. The timing of their fishing expeditions, potlatch ceremonies, and even tribal councils followed patterns based on generations of observations connecting lunar phases to tidal abundance. Perhaps most remarkably, cultures separated by vast oceans and thousands of years independently developed similar beliefs about lunar influence on human behavior and health. Chinese traditional medicine has long held that the body's vital energy, or qi, flows in patterns synchronized with lunar phases, with treatments timed to coincide with specific moon cycles. Medieval European physicians believed that surgical procedures should be avoided during full moons, when they theorized that increased tidal forces in bodily fluids might cause excessive bleeding. Even today, these ancient intuitions persist in surprising ways. Emergency room workers often report busier nights during full moons, though scientific studies have found no statistical correlation. Farmers still consult lunar calendars when planning plantings, particularly in regions where traditional agricultural knowledge has been passed down through generations. Coastal communities worldwide maintain festivals and rituals that celebrate the connection between lunar cycles and tidal abundance. The word lunatic itself preserves humanity's ancient belief in lunar influence on human consciousness, while moonstruck captures the persistent notion that lunar phases can alter perception and behavior. Modern research in chronobiology, the study of biological rhythms, has found that while the moon's gravitational influence on individual humans is negligible, our evolutionary history and tidal environments may have encoded lunar sensitivity into our genetic programming in subtle but measurable ways. These myths and legends weren't simply primitive attempts to explain natural phenomena. They were sophisticated, metaphorical systems that encoded practical knowledge about timing, navigation, and survival in languages of story and symbol. The moon goddess pulling tides was a memorable way to teach young people about gravitational relationships they couldn't see but whose effects they could predict. And as we explore these rich tapestries of human imagination, we discover that our ancestors' myths about lunar magic contained kernels of truth that modern science is only now beginning to fully appreciate. But what biological realities might underlie these ancient intuitions about moon, tides, and the rhythm of life? Beneath the waves, in the warm shallows of coral reefs around the world, one of nature's most spectacular synchronized events unfolds according to a schedule written in starlight and tidal mathematics. On specific nights each year, when lunar phases align with seasonal rhythms, millions of coral polyps release their eggs and sperm simultaneously, turning entire sections of ocean into clouds of new life. This mass spawning event, timed to the minute by lunar calendars encoded in coral DNA, represents just one example of how deeply tidal and lunar rhythms have penetrated the biological programming of life on Earth. The phenomenon is so precise that marine biologists can predict exactly which reefs will spawn on which nights, sometimes months in advance, by consulting astronomical tables and understanding each species' particular relationship with cosmic cycles. Along the beaches of the eastern United States, another ancient ritual unfolds with similar precision. Horseshoe crabs, living fossils whose ancestors swam in Paleozoic seas hundreds of millions of years ago, emerge from deep waters during spring tides to mate and lay eggs on sandy shores. Their timing is exquisite. They arrive precisely when highest tides will provide maximum access to prime nesting beaches, and depart before lower waters might strand them in lethal shallows. This horseshoe crab congregation creates a feast that sustains one of North America's most remarkable wildlife spectacles. Red knots and other shorebirds time their spring migration to coincide with crab spawning, arriving from Arctic breeding grounds just as beaches become carpeted with protein-rich eggs. The birds must double their body weight during this brief tidal window to fuel the final leg of their journey, a testament to the precision of biological clocks synchronized with lunar and tidal cycles. In tropical waters around the Pacific, the grunion fish of California beaches perform an even more dramatic tidal ballet. These silver fish ride the waves onto sandy shores during the highest spring tides, spawn in the wet sand just above the tide line, then return to the ocean on the next wave. Their eggs develop in the moist sand for exactly 2 weeks, one complete lunar cycle before the next series of spring tides washes the hatched larvae back to sea. The precision required for this reproductive strategy seems almost impossibly complex. The adult fish must predict not just the timing of spring tides, but also the exact height those tides will reach on specific beaches. They've essentially evolved to surf, using wave action to reach spawning sites that will remain safely above normal high tide levels long enough for their offspring to develop, yet be accessible to the liberation tides 2 weeks later. These spectacular examples represent just the visible edge of a vast network of biological rhythms synchronized with tidal and lunar cycles. Marine worms emerge from their burrows to spawn during specific moon phases. Sea urchins coordinate their reproductive releases with tidal cycles that will carry their gametes to optimal mixing zones. Even microscopic plankton adjust their vertical migrations in the water column according to tidal rhythms, rising toward the surface during slack water and diving deeper during strong currents. Perhaps most remarkably, some of these tidal clocks continue running even when animals are removed from tidal environments entirely. Oysters transported to inland laboratories maintain rhythmic opening and closing patterns that match the tidal schedule of their home waters. Fiddler crabs kept in constant laboratory conditions continue displaying color changes synchronized with tidal cycles from beaches hundreds of miles away. These persistent rhythms suggest that tidal timing has become so fundamental to these creatures' biology that it operates like an internal metronome. Independent of external cues, the influence extends to terrestrial ecosystems as well. Coastal forests experience subtle but measurable changes in sap flow that correlate with tidal cycles. Some flowers native to tidal marshes open and close their petals in rhythm with nearby tides, maximizing pollination opportunities during specific tidal phases when insect activity peaks. Even inland plants show statistical correlations between germination rates and lunar phases, suggesting that ancient evolutionary connections to tidal environments may persist. In their genetic programming, modern research in chronobiology has revealed that these tidal and lunar rhythms operate through some of the same molecular mechanisms that govern circadian clocks, the internal timekeepers that regulate sleep-wake cycles, hormone production, and cellular repair processes in virtually all living things. This suggests that life's relationship with cosmic cycles extends far deeper than simple behavioral conditioning, reaching into the fundamental biochemistry of existence itself. As we contemplate this hidden network of biological clocks, all synchronized with the same celestial conductor, we begin to appreciate how profoundly the moon's gravitational influence has shaped not just the evolution of individual species, but the development of Earth's entire biosphere. But how might these ancient rhythms manifest in our own species, creatures who have seemingly disconnected ourselves from natural cycles through technology and artificial lighting? In a small coastal village in Nova Scotia, lobster fisherman Daniel MacLeod still sets his traps according to his grandfather's lunar calendar. Handwritten notes passed down through 4 generations of maritime knowledge. He doesn't consult satellite weather data or oceanographic models. Instead, he reads the moon's phases like a pocket watch, timing his deepest water excursions for the days, following the new moon when tides run strongest and lobsters feed most. Actively in the darkness, Daniel represents a living link to humanity's ancient partnership with lunar rhythms, a connection that shaped our species long before electric lights divorced us from natural cycles. For most of human history, people planned their most important activities around lunar phases, not because of mystical beliefs, but because careful observation had taught them that certain endeavors succeeded best when aligned with these cosmic cycles. Farmers throughout history have planted and harvested according to lunar calendars, timing their work to coincide with specific moon phases. Modern agricultural research has found statistical correlations supporting some of these traditional practices. Root vegetables planted during waning moons often show improved storage characteristics, while crops requiring vigorous leaf growth may benefit from planting during waxing lunar phases. The mechanisms behind these correlations remain mysterious, but the empirical results continue to influence farming practices worldwide. In traditional Chinese medicine, practitioners still time acupuncture treatments and herbal prescriptions according to lunar phases, believing that the body's energy meridians fluctuate with celestial cycles. While scientific validation of these practices remains inconclusive, some modern research has found intriguing correlations between lunar phases and certain physiological processes. Hospital admission rates for certain conditions show statistical variations that align with lunar cycles. Though the effect sizes are small and the mechanisms unclear, perhaps nowhere is humanity's relationship with lunar rhythms more evident than in our reproductive biology. The human menstrual cycle averages approximately 28 days, remarkably close to the Moon's 29.5-day orbital period. This synchronization has led researchers to investigate whether human fertility once aligned more closely with lunar phases, particularly in populations living without artificial lighting. Studies of traditional societies with minimal artificial illumination have found that women's menstrual cycles do show statistical clustering around specific lunar phases, with ovulation often occurring during either full or new moons. Some researchers theorize that before electric lighting disrupted our natural circadian rhythms, lunar cycles may have provided the primary environmental cue for coordinating human reproductive timing, a phenomenon still observed in many other mammalian species. Modern urban dwellers, surrounded by artificial lights and climate-controlled environments, might assume they've escaped lunar influence entirely. Yet subtle connections persist. Sleep studies using actimetry devices have found that people tend to sleep less deeply and wake more frequently during full moon periods, even when sleeping in windowless rooms with no conscious awareness of lunar phases. The effect is small, typically amounting to about 20 minutes less deep sleep, but statistically significant across large populations. Emergency room workers and police officers often report subjectively busier shifts during full moons, though rigorous statistical analysis of emergency department records fails to support these impressions consistently. However, some studies have found correlations between lunar phases and specific types of incidents. Psychiatric emergencies, for instance, may show slight increases during certain lunar phases, though the effects are subtle and may be influenced by confirmation bias in reporting. More intriguing are recent discoveries about human circadian rhythms and their potential connections to longer cycles. Researchers studying isolated communities in the Arctic, where seasonal light variations are extreme, have found evidence that human biological clocks may operate on multiple timescales simultaneously. While the primary circadian rhythm runs on a roughly 24-hour cycle, secondary rhythms appear to fluctuate on weekly and monthly timescales that sometimes correlate with lunar periods. The influence may extend to cognitive and emotional patterns as well. Some psychological studies have found subtle but measurable variations in human mood, creativity, and decision-making that correlate with lunar phases. Artists and writers have long reported feeling more creative during certain moon phases, and while much of this may be cultural conditioning, emerging research in neuroscience suggests that circadian rhythms can influence higher-order brain functions in ways that might be sensitive to environmental cycles. Perhaps most remarkably, modern technology is revealing connections our ancestors could never have imagined. GPS satellites must account for lunar gravitational effects when calculating precise positions. The atomic clocks used for internet synchronization show minute variations that correlate with tidal forces. Even smartphone accelerometers, sensitive enough to detect the tiny gravitational variations caused by lunar position, are beginning to reveal subtle patterns in human movement and activity that align with celestial mechanics. As we rediscover these ancient connections between human life and lunar rhythms, we're forced to confront a profound question. In our rush to master our environment through technology, have we severed connections that once provided essential guidance for health, creativity, and community coordination? And what might happen to these delicate biological relationships if the cosmic balance that created them begins to shift? Tonight, as you observe the moon's familiar face gazing down from its accustomed place in the sky, you're witnessing something far more fragile than it appears. This celestial partnership that has governed Earth's rhythms for billions of years exists in a delicate equilibrium that could be disrupted by changes we're only beginning to understand. Consider what Earth would be like without its lunar companion. Computer models of such a world reveal a planet almost unrecognizable as our home. Without the moon's gravitational anchor, Earth would wobble chaotically on its axis, tumbling through space like an unbalanced top. Seasons would shift unpredictably. Tropical regions might freeze for centuries while polar areas baked under endless summer heat. The stable climate that allowed complex life to evolve would never have existed. The ocean, freed from lunar control, would experience only weak solar tides rising and falling by mere inches instead of feet. Coastal ecosystems as we know them couldn't exist. There would be no intertidal zones with their rich communities of specialized organisms. No tidal mixing to distribute nutrients through marine food webs. No tidal energy to drive the ocean currents that moderate global climate. But this isn't merely a thought experiment about an impossible world. The Moon-Earth system is actually changing, and those changes are accelerating due to human activities in ways that could fundamentally alter the balance we've taken for granted. Rising sea levels, driven by thermal expansion of warming oceans and the melting of polar ice sheets, are changing tidal patterns in measurable ways. As water depth increases in coastal areas, tidal ranges are shifting, some locations experiencing higher high tides while others see their tidal ranges diminish. These changes propagate through coastal ecosystems like ripples from a stone dropped in still water, affecting everything from salt marsh vegetation to migratory bird populations that depend on precisely timed tidal exposures. More concerning are the feedback effects. As ice sheets melt and redistribute mass from polar regions to the oceans, Earth's moment of inertia, its resistance to rotational change, is gradually shifting. This affects the rate at which tidal friction slows our planet's rotation, potentially altering the delicate gravitational dance between Earth and Moon in ways we're still learning to predict. Coastal development compounds these changes by altering the geography that shapes local tidal patterns. When we fill wetlands, build seawalls, and channelize rivers, we change how tidal energy dissipates along coastlines. Cities like Venice, built in careful harmony with their tidal environment, now find their ancient flood defenses inadequate as both sea levels and tidal patterns shift beyond historical ranges. The consequences extend far beyond flooded streets and disrupted ferry schedules. Estuarine ecosystems, among the most productive on Earth, depend on precise timing of freshwater flow and tidal mixing. As these patterns change, the nursery areas that support commercial fisheries begin to fail. Salt marshes that have served as storm buffers for thousands of years find themselves either permanently flooded or stranded above the tide line as patterns shift. Climate change adds another layer of complexity. Warming oceans expand, contributing to sea level rise, while changing weather patterns alter the atmospheric pressure systems that can amplify or dampen tidal effects. Storm surges, riding atop higher baseline sea levels, create compound flooding events that exceed all historical precedents. Perhaps most troubling are the potential cascade effects. If changing tidal patterns disrupt the biological clocks of key species, the mass spawning of corals, the migrations of fish, the breeding cycles of shorebirds, entire food webs could collapse in ways that ripple through marine ecosystems globally. The horseshoe crab spawning that fuels shorebird migration could be displaced in time or space, breaking a synchronization that has persisted for millions of years. Yet within these challenges lies an opportunity for deeper understanding. The rapid changes occurring today are creating natural experiments that allow scientists to study tidal dynamics in real time rather than reconstructing them from geological records. Satellite altimetry, GPS monitoring, and deep ocean sensors are creating unprecedented datasets that reveal how tidal systems respond to changing boundary conditions. This knowledge could help us adapt more wisely to changing conditions. Understanding how tidal patterns respond to sea level rise, for instance, might inform coastal planning decisions that work with natural processes rather than against them. Predicting how changing tidal regimes will affect marine ecosystems could guide conservation efforts toward protecting the most critical habitats and migration corridors. The Moon continues its ancient orbit, pulling tides across oceans as it has for eons. But the Earth those tides wash over is changing rapidly, and our species has become a force powerful enough to alter the planetary systems that shaped our evolution. The question facing us now is whether we can learn to use this power wisely, preserving the delicate balance that has sustained life on Earth while adapting to changes that may be inevitable. As we contemplate these fragile relationships, we might wonder, could our growing understanding of lunar and tidal dynamics help guide humanity's expansion beyond this single world? carrying Earth's rhythms to new planets that orbit distant stars. As humanity prepares to return to the moon with permanent bases and expanding settlements, we're discovering that our relationship with our celestial companion is about to enter an entirely new phase. The same gravitational forces that have shaped Earth's tides for billions of years may soon become tools for human survival and exploration beyond our home planet. NASA's Artemis program and private space ventures are planning lunar colonies that will depend on understanding tidal forces in ways our Earthbound ancestors never imagined. On the moon itself, Earth appears as a blue marble hanging in the black sky, creating Earth tides in the lunar crust that could provide geothermal energy for future settlements. These solid-body tides, caused by Earth's gravitational pull on the moon's rocky interior, generate enough heat through internal friction to potentially power lunar habitats and manufacturing facilities. But the implications extend far beyond lunar colonization. Our growing mastery of tidal dynamics is teaching us how to recognize potentially habitable worlds around other stars. Exoplanet researchers now search for planets in complex gravitational relationships that could generate tidal heating, the same process that keeps subsurface oceans liquid on Jupiter's moon Europa and Saturn's Enceladus. These tidally heated worlds might harbor life in places we once thought too cold and distant to support it. The techniques we've developed for predicting Earth's tides are being adapted to model the complex gravitational interactions in multi-planet systems around distant stars. Some exoplanets experience tidal forces so extreme they're tidally locked to their suns, with permanent day and night sides. Understanding how such worlds might maintain stable climates requires applying our knowledge of tidal dynamics on scales far greater than anything in our solar system. Future interplanetary travelers will need to master tidal navigation in ways that would astound ancient Polynesian wayfinders. Spacecraft traveling between planets must account for the gravitational tides created by multiple bodies, the sun, planets, and moons, all contributing to complex force fields that can either assist or hinder a journey. Mission planners already use gravity assists that essentially harness tidal forces to slingshot spacecraft toward distant destinations with minimal fuel consumption. As we establish permanent settlements on Mars, tidal knowledge will prove crucial for understanding that planet's unique environment. Mars has two small moons, Phobos and Deimos, that create negligible tides compared to Earth's lunar companion. This absence of strong tidal mixing may be one reason Mars lost its thick atmosphere and surface water. Without tidal energy to drive ocean circulation and atmospheric mixing, the planet couldn't maintain the stable climate necessary for retaining its early, warmer conditions. The moon itself may become humanity's stepping stone to the stars. Its low gravity and lack of atmosphere make it an ideal launching point for deep space missions. While its position in Earth's gravitational well provides natural advantages for certain types of space manufacturing, factories in lunar orbit could use tidal forces to provide artificial gravity for industrial processes while remaining accessible to both Earth and lunar surface facilities. Perhaps most remarkably, our expanding understanding of tidal forces is revealing new possibilities for generating clean energy on Earth. Tidal power stations already harness the moon's gravitational pull to generate electricity, but emerging technologies could capture tidal energy more efficiently and in more locations. Some engineers envision artificial tidal lagoons and underwater turbines that could make tidal power a major contributor to renewable energy production. The knowledge we gain from living and working in space will likely transform our understanding of Earth's own tidal systems. Observing our planet from lunar bases will provide new perspectives on global ocean circulation, climate dynamics, and the complex interactions between tidal forces and atmospheric patterns. Space-based sensors could monitor Earth's tides with unprecedented precision, improving both climate models and tsunami warning systems. Future generations may grow up with an intuitive understanding of gravitational dynamics that spans multiple worlds. Children born on lunar colonies will experience Earth's tides as distant phenomena observed from space, while those living on Mars will know only the weak tidal forces of its tiny moons. Yet all will be connected by the same fundamental physics that governs how massive objects interact across the vast distances of space. As we prepare to carry Earth's life beyond our home planet, we're learning to see tidal forces not just as natural phenomena to be studied, but as tools to be mastered and resources to be harvested. The moon that once served only as Earth's timekeeper and tide puller may become humanity's partner in exploring and settling the cosmos. The eternal dance between worlds continues. But we are no longer merely observers of this cosmic choreography. We are becoming participants, learning to move in harmony with gravitational rhythms that connect not just Earth and Moon, but all the worlds that circle all the stars in the vast symphony of space. As our journey through time and tide draws to its gentle close, step outside once more and feel the night air against your skin. Somewhere in the distance, waves are breaking against an unseen shore, keeping time to the same rhythm that has pulsed through Earth's veins for 4 billion years. Above you, the moon continues its patient orbit, pulling those distant waters in the same gravitational embrace that shaped the first tides when our planet was young and our species was still a distant dream. But in this quiet moment, you are connected to everything we have discovered together. The calcium in your bones was forged in the cores of dying stars. The water in your cells once rose and fell with ancient tides, and the very rhythm of your heartbeat echoes the cosmic dance that governs worlds. You are not separate from the forces we have explored. You are part of them. A brief arrangement of atoms that learn to contemplate the universe that created it. The moon above you tonight is the same celestial companion that guided Polynesian navigators across trackless oceans, inspired countless generations of poets and dreamers, and served as humanity's first calendar and clock. It has watched civilizations rise and fall, species evolve and disappear, continents drift and collide. Through all these changes, it has maintained its vigil, pulling the tides that mix the oceans, stabilize the climate, and provide the rhythm that life learned to follow. This rhythm will continue long after our current concerns have faded into history. The moon will keep drawing tides across Earth's shores for billions of years to come, though those tides will be different from today's as the cosmic dance evolves. Gradually, imperceptibly, the moon will drift farther from Earth, days will grow longer, and tides will grow weaker. Eventually, if both worlds survive the sun's expansion into a red giant, Earth and Moon will become tidally locked, two worlds forever facing each other across the void like eternal dance partners. But tonight, in this present moment that exists between an ancient past and an unimaginable future, you can simply listen to the eternal rhythm that connects all things. In the whisper of wind through leaves, in the distant sound of waves, in the beating of your own heart, you can hear echoes of the same forces that shaped galaxies and birthed planets, that lifted the first tides on the first oceans, that will continue their cosmic dance long after the last human story has been told. Sleep peacefully in this knowledge. You rest on a world held in gravitational embrace by its faithful companion, surrounded by oceans that breathe with cosmic rhythm, part of a universe where even the grandest forces, gravity, time, the formation and destruction of worlds, ultimately serve to create moments of perfect stillness like this one, where consciousness can pause to contemplate the wonder of its own existence. The tide rises and falls. The moon continues its journey across the star-filled sky, and somewhere in the gentle rhythm that connects these eternal cycles, your dreams will find their own cosmic cadence, carried by forces older than memory toward the peaceful shore of sleep.